Hello guys, can you hear me? Let me see. Okay, now you should hear me well. Hi guys, is everything okay with my voice and everything? Guys, you might see me a bit blurry today because this camera, my webcam camera, has some issues. I'm not sure what is the issue. I tried to fix it in many different ways, but it hasn't fixed yet. But I hope that it doesn't cause any issues and you can see me well and understand me well. Okay, how was today's contest for you guys? Shall we start talking about the problems? Hi. Okay. A was easy. I got ducked in everything else. Okay. I see. Yeah, today, and I'm sorry that I was late, guys. So sorry for that. Today, again, I don't know why all the contests are recently at the times that I'm out. I'm not at home. Thanks God, tomorrow I'm gonna be at home when the contest is going to happen. So tomorrow we won't have delay and we're gonna have a longer stream tomorrow. Today I just could read several problems from the beginning. We're gonna solve those ones. So today's live stream is gonna be a bit shorter. Maybe we're gonna solve A to D. So it's gonna be a bit shorter. Yes, camera is a bit blurry. I told you that it has some issues. It's not about cleaning. By cleaning, like this. It does not change. It became worse. So it's some issues that I need to fix it. I need to find out what's the issue. Thank you very much, Samyak. Thanks a lot. Okay, so if you guys are ready, let's start talking about the problems. Let's start from problem A and talk about this problem. We're gonna solve from A possibly to D. Okay, let's jump to the problems. Okay, so the first problem, set. You are given a positive integer k and a set S of all integers from L to R inclusive. You can perform the following two-step operation any number of times, possibly 0. First, choose a number x from the set S such that there are at least x multiples of x in S. Then remove x from S. Note that nothing else is removed. Find the maximum possible number of operations that can be performed. So, you want to find out the maximum possible number of operations that can be performed in here. So, what I say is this. I say that let's try to find out initially. If we want to use all the numbers that they are gonna be, let me see myself as that they're gonna have at least k multiples. Okay, we want them to have at least k multiples, right? I guess that you are seeing me a bit lag, and let me also move a little bit here. So I'm saying that if you start from the greatest integers, if you choose some integers that they have k multiples, let's consider all the numbers that they have at least k multiples. What is the condition for a number to have at least k multiples in the range from L to R? We want a number x to have at least k multiples in the range from L to R. What is the condition for that? R over k, what do you mean? I know that what do you mean, but it's good to explain to the others as well. X times k is less than max. Exactly. It must be less than or equal to max. X times k must be less than or equal to R. Only in this situation, this number has k multiples at the beginning. So at the beginning, I start by saying that for some number x, x times k must be less than or equal to r, such that then it can have k multiples. Then x, 2x, 3x, 4x, 2kx are going to be at most r. So this way I can say that this number has k multiples. Now let's consider all such numbers that they have k multiples, all such numbers from L to the maximum such number that can have k multiples. Let's take a look at all these numbers. I'm saying that if you start from the maximum number and each time do an operation on one of them, each time you do an operation in one of them, I think you can do operations on all of these numbers. I say that you can do operation on all of these numbers, and all of them are gonna have k multiples when we get to them. Why? Because basically I'm saying that deleting a number from here will have no harmful effect on numbers before it. I mean, it's not possible that maybe you had a number in here such that it is a multiple of that, and when we delete this one will not have k multiples anymore. Why? Because when we delete this number itself has at least k multiples. So there are at least k minus 1 numbers greater than this, such that there are multiples of this. If it has a harmful effect on another number, these k minus 1 numbers exist for that number as well, and that number itself exists too. So I'm saying that yes, maybe you will delete this one from the multiples of that number. When it will be deleted, it will not be a multiple of that number anymore in the set as well. But the point is that instead of this number itself will be added, and therefore it still has at least k multiples. So when you start from the largest number and go to the smallest number, by doing this, nothing bad will happen. Also, if you start from the smallest number and go to the largest number, basically the numbers greater than your number are not deleted yet. So therefore, again, all the numbers are gonna have the k multiples as well. So I'm saying that in both ways, I mean in any of these two ways, if you go, all these numbers that you will delete will have at least k multiples. You might ask that why I said going reversed first, because if we go forward, it's gonna be way easier. I mean, I just wanted to mention that you could also, even if you would go from the ends to the beginning, that would still work and there wouldn't be any issue. So basically, I mean that both of the ways work. So if you find all the numbers such that they have k multiples in this range from L to R, all such numbers are gonna have this condition that we want. Therefore, it will work in total. So I can find the greatest x such that x times k is less than or equal to r. And what is that greatest x? You can easily say that, I mean by a little bit. Binary search would also work as well, but you don't need binary search. Thank you, Marcus. But you don't really need binary search. Yes, it could also happen. You could also do it without the binary search. It kind of is an overkill. I mean, we could also say that x will be at most k over r over k, the floor of r over k. So my x will be at most floor of r over k. So my answer is going to be maximum of floor of r over k minus L plus 1, because this is the maximum number such that it has k multiples, this is the minimum number such that it has k multiples, and we have to add 1 to it as well when we want to see how many numbers are in this range, and 0, maximum of this and 0. This is gonna be my answer. And you can easily see in L, R and K and see out this value, maximum of R over K minus L plus 1 and 0. This way your answer will be calculated. Is it clear for you guys? If you are completely okay with that, please put a plus in the chat or use this emoji. Sorry for drinking. Okay, nice. Nice. Why you subtract L? Well, because your number must be at least L. I mean, all the numbers that you have are from L to R. So you want to delete the numbers. The minimum number that you have is L, and the maximum you have is R over K. You cannot delete the numbers less than L. You cannot delete the numbers from L minus 1 to 1. So the range of the numbers that you can delete is from L to R over K, floor of R over K. So this is the range. The length of this range is R over K minus L plus 1, maximum with 0, because maybe this would be less than L and you should not print a negative number in that case. So you have to take the maximum with 0. Okay, is it clear for everyone then? Nice, nice. Awesome. So, awesome. Good vibe. Nice. What is good vibe in here? Yeah, I will move on. How you approach a question when I think of multiple cases, I got confused. Well, basically, as always, you have to experience solving a lot of problems in order to be able to solve the problems easier. And guys, I guess that my video has some lag, right? I mean, I see some lag in my video in here. I hope that it would work well. Okay, so let's move on now to the next problem, problem B. Problem B says that you have a binary string S of length n and RS gives you another binary string R of length n minus 1. RS is going to play a game with you. During the game, you will perform n minus 1 operations on S. In the ith operation, first you choose an index k such that k is at most size of S minus 1 and S sub k is not equal to S sub k plus 1. If it is impossible to choose such an index, you will lose. Then you will replace sk plus 1 with ri. Ri's are given to you as well. You are given this string r as well. And if all the n minus 1 operations are performed successfully, you will win. Determine whether it is possible for you to win this game. So basically, each time you can choose 2 consecutive letters, 2 consecutive digits, binary digits. And if these 2 bits must be different. If they are different, you can delete these 2 and replace them with r sub I in operation number I. So this is gonna be, this is the question. So basically, I can say that, assume that, for example, I have these 2 numbers. Assume that Ri is 0. I want to look at the problem differently. I want to look at it in somehow else, in another way. So if Ri is equal to 0, if you consider these 2 consecutive digits, one of them must be 0, one of them must be 1. So you have 1 0 1 1, for example. Either there is 1 0 1 or 1 0. And you can delete them and instead of them put a 0 if Ri is equal to 0. So we can look at it that it is like I'm removing a 1 from my string. So I'm saying that you can look at it in another way. It's like in this operation, I'm choosing one of the ones and I'm deleting it. And the point is that, so basically, when Ri is 0, it's like you want to choose one of the ones and delete them. And if it is 0, if it is 1, it's like you want to choose one of the zeros and delete them. So for example, in here you have 0, 0, and 1. When we see a 0, it's like we have to delete a 1. So I can choose this 1, 0, and can delete this 1. And then in the next operation, I can choose this 0 and this 1, and I can delete this 1. At the end, I'm going to have only this first 1 and this 0 at position 3, and I can choose these 2 and replace them with a 1. So basically, the other way that I'm looking at it is that instead of assuming that I'm replacing a 0, 1 or a 1, 0 with a 0, I'm looking at it, it's like I'm deleting a 1. And vice versa for the other case. If I'm replacing them with a 1, it's like I'm deleting one of the zeros. And the point is that if I only keep the count of the 1s and the 0s, it's enough. Because I'm always able to delete one of the ones and one of the zeros if both numbers are greater than 0. If I have x ones and y zeros, if both of these numbers are greater than 0, if both x and y are positive, I can always find two adjacent digits, two adjacent bits such that they're different. I mean, you can consider the first, each time, you have some zeros and some ones. So basically, you need to, at some point, have two consecutive digits such that they are different at some point. Otherwise, all the numbers are equal. So if x and y are both greater than 0, you can always find such numbers. So basically, I can just keep the number of ones and zeros that I have. I can just keep them. And then each time I see that if I want to delete a 0 or I want to delete a 1, first of all, both of them must be greater than 0 if I want to do an operation. Both of them must be greater than 0, and if that is the case, I have to decrease 1 from one of these two numbers. And if I want to dry run a case, for example, in here, consider this example. So far is it clear before dry running? After that I will dry run and we will see how it would work. If so far it is clear, please put a plus or use this emoji. After that I will dry run on a sample. Awesome. Nice. Thank you, Pamanio, if I pronounce it correctly. But if we were also asked the indices of the operations performed, I will talk about that as well. Yes, it's basically, yes. Okay, I will run now, dry run, and explain it better as well so that you'll understand it. So you have 1, 1, 0, 1, and Ri's are 0, 0, 1. So I'm saying that let's keep the number of zeros and ones that you have. In here you have, for example, x is, for example, the number of ones, as I said before, is 3, and y is equal to the number of zeros, it is 1. I'm saying that each time that you want to do an operation, both of them must be positive. So you need at least 1 0 and you need at least 1 1, because each time you want to choose two consecutive elements such that they're different. And if you have them, if x and y are both positive, you definitely are going to have two consecutive numbers such that they are 0, 1 or 1, 0. You're definitely going to have two such numbers. So basically, I just need to know the count of ones and the count of zeros. How many ones do I have? How many zeros do I have? And when I see a 0, I know that I'm going to replace a 0, 1 or a 1, 0 with a 0. So it's like I will subtract 1 from x. So this 3 becomes 2. Then I see another 0. I see both of them are positive. So it is okay. I can do an operation. And then this is 0. So I need to subtract 1 from the number of ones again. So this becomes 1. Then I see 1. So this time I have to subtract from the number of zeros. And I see both of the numbers are greater than 0. So it's okay. I will just subtract 1 from it. It will be 0. So basically it would be like this. And if I take a look, let's take a look at another example such that its answer is 0. For example, let's take a look at this one. Let's see if I can copy and paste it here. I'm not sure if I can copy that. So it's 1 0 0 1 0 0 1 0. So the another example, it's 1 0 0 1 0 0 and 1 0. And the other one I think was 0 0 1. Yes. 0 0 1 0 0 1 0. So if you take a look at it, initially x, my value of x is 3, I have 3 ones, and my value of y is 5, I have 5 zeros. Let's start from the beginning. First I see a 0. So I should subtract x or I should subtract y? Can you tell me? First of all, the first number that I see is a 0. So I should subtract from x or I should subtract from y? Exactly. I should subtract from x, from the number of ones. Yes, exactly. We just need how many ones do we have, how many zeros do we have. Yes, exactly. So I see 0. So I know that I will delete one of my ones. So x will be subtracted by 1. X will be 2. Then again I see a 0. Again I have to subtract 1 by x by 1. Again, now I see a 1. Now I see both of the numbers are positive, so I can do an operation, and then I will subtract this by 1. Then I see a 0. I see both of the numbers are positive. I have to subtract this one by 1. Now when I see a 0, I see that my x is 0. So in my string, everything is 0. I have no ones. I have 0 ones. I have no ones. So everything is 0 in my string. So I cannot do an operation anymore. So I will terminate my code here, and I say that there's no answer. I will print that it's not possible. I should print no in this case. I will just print no. So I just keep track of x and y, and each time I know that which of these numbers I should decrease. And if one of them became 0 when I wanted to do an operation, I wanted to do an operation, but it was 0. At the end, one of them becomes 0. But the point is that while we are doing operations, they must not become 0. And if they become 0, I will say that it is not possible. Otherwise, it's possible to do all the operations. Let me also show you some code. If you take a look at this code, this also helps you to understand it better. You just see in S and R, you will see that 0 is the number of zeros that we have, 1 is all the other numbers, and 1 is the number of zeros. And each time, I mean, his implementation is like this. He will subtract both and then see if one of them became negative. The answer is no. And at the end, the one that must not be decreased, he will increase it back again. So basically, what he's doing basically is this. He's saying that when he does an operation, he could instead just say this. If 1 was 0 or 0 was 0, he can see out no. Otherwise, if c is 1, you can see that 0 will be subtracted by 1, because 1 will be subtracted here and here will be added again. And if c is 0, 1 will be subtracted by 1. Maybe I can show you another code as well. This code, if you take a look at it, he each time sees that if minimum of CNT of 0 and CNT of 1 was 0, he will say okay equal to 0. Otherwise, he will subtract 1 from the zeros, subtract 1 from the ones, because 2 characters will be deleted, and the other character that will be added, its CNT will be increased. And he just needs to make sure that none of these 2 characters become 0. The number of none of these 2 characters becomes 0. That's the only condition. We should not run out of zeros or ones when we want to do operations. That's the only conditions that we should have. Is it completely clear now? Did you all understand? Awesome. Nice. So shall we move on to problem C then? You just explained it so easily that I understood clearly in the very first minute. Awesome. I'm so happy to hear that. Okay. Now you ask that what if we wanted to also print the indices? Well, if you want to print the indices, you can keep a set of the zeros that you have and the ones that you have. You can keep a set of zeros and ones that you have. And I'm basically, as the indices, I want to say that you can each time consider the first time that you have a 0, 1 or a 1, 0. So if your first character is 0, if your first bit is 0, try to find the first 1 that you have and pick that 1 and the element before that. If your first bit is 1, try to find the first 0 and choose that 0 and the bit before that. So I can have 2 sets. This is the indices of all the zeros, this is the indices of all the ones. Each time I see that what is the minimum element in the first set, what is the minimum element in the second set. I see these minimum elements and I see which one is bigger. The one that is bigger, I pick that one with the element before that one. The element before that one necessarily is the other bits. If this way, if your first digit left is 0, you will find the first 1 and pick that one with the one before that. If the first bit is 1, you will pick the first 0 and the one before that. And this way you can delete two digits and replace it with another digit. So this, when you choose these two, I mean, you can easily see that what is the index of that one, and then delete these two, and then put another digit instead, for example. So this is, for example, how you can find, if you were supposed to also print the indices. My idea was this: just keep two sets of the remaining indices, and each time just try to find out the minimum of these two sets, which one is bigger. Just choose the one that is bigger with the element before that one. And this way you could do the operations themselves as well. This is not important, this is not the problem. I mean, this is just if hypothetically you were supposed to also say that what are the indices, then you could do it like this. You could solve it like this. Is it clear now? Shall we move on to problem C? What is the difficulty? You're asking about the difficulty. Right now we are in question B. Why there was less participants in this contest? I'm not sure about it, but I guess usually in these 2 and these 3 contests there are more people usually. And tourists did not participate today. It's a shame. So tourists still hasn't participated in the contest, and Bank has won the first rank today. Okay. How could I be good at CP? Any tips? Well, you can join our Telegram channel. In our Telegram channel, we talk a lot about. I mean, I do all the announcements typically about the topic streams that we have that I'm gonna teach every topics, and you can have chats with others. And we will also talk about which type of videos you want me to make so that it would be helpful for you guys. So if you want, you can join our Telegram channel in here. Also, I've made a Codeforces group recently, such that we're gonna start having contests in that Codeforces group. We're gonna have contests in that Codeforces group in each of the topic streams that we have. I'm gonna first add them in the Codeforces, add a contest in the Codeforces group so that you can participate and solve the problems yourself, and then I will solve them in a topic stream, because you suggested that this way it would be more beneficial for you if we do this. You said that you would like to. I put a vote in Telegram, and most people said that they want to have this contest, and it's going to be helpful. So if you want, you can join this Codeforces group as well. And we will put the topic streams as a contest, all the problems as a contest in this Codeforces group first. You can participate in that and then come to the topic stream and listen to all the solutions. And if you want to see the previous topic streams, you can see them here. All the topic streams, you can see them in here. About the guideline videos, tips, and what we can do to improve in CP, I have made 2 videos so far, especially about the newbies. You can watch them for now, and I also plan to make more videos about that. And in our Telegram channel, I will put a vote on why I'm looking at that. This is the camera. In our Telegram channel, I would also put a poll to see that's what you guys want to talk about in the next topic streams, and also in the next videos that I'm gonna make to our guidelines. So you can join there and participate in our votes, and together we can decide what sort of materials you guys want. But basically, at the end of the day, the most important thing for you is to try to solving so many problems. That's the most important thing that you have to do in CP. Okay, let's move on to problem C now. Problem C, new rating. This problem says that Kevin is used to be a participant of Codeforces. Recently, the KDOI team has developed a new online judge called Forces Code. Kevin has participated in N contests on Forces Code. In the ith contest, his performance rating is A sub I. Now he has hacked into the backend of Forces Code and will select an interval LR, then skip all of the contests in this interval. After that, his rating will be recalculated in the following way. Initially, his rating is x equal to 0 for each I from 1 to n. After the ith contest, if the performance in that contest is greater than his current rating, his rating will increase. If it is equal, his rating will remain unchanged. If it is less than the current rating, his rating will decrease by 1. You have to say that what is the rating what is the maximum rating that he can achieve if he skip an interval of the contests. So my idea to solve this problem was DP. I think that you can have 3 states. Basically, you can have 3 states. So in general, when you want to use DP, you can always look at it like this. It's like you have to define several states. As I told you in the previous topic streams that I had on DP, the main thing about DP, if you remember, we had 4 phases for DPs. 4 phases to define a DP. I mean, finding the base cases and defining the states and updates, and then saying that which cell is the final answer. I'm saying that in here you have 3 states in general. When you go forward and you get to I, when you go forward and you get to some I, basically there are 3 cases. Either you haven't started that interval that you're gonna skip the contests, or you have started it and you haven't finished it yet, so you have started the interval that you are skipping the contest, but you have not finished it yet, so you can still skip the next contest as well. Or you have started it and also you have finished it. So basically there are three cases. Either you have not yet started the interval that you want to skip, so you're going to do it later. You're going to skip an interval later. So this is going to be dp of I and 0. The max rating that you can have if you haven't skipped anything. dp of I and 0 can be easily calculated. I mean, it's just some for each time you can see if rating increases or decreases. It's basically you haven't skipped anything. dp of I and 1 means that you have skipped some of them and the last one is also skipped as well. The last one is also skipped as well. dp of I and 0 is definitely dp of I minus 1 and 0 is based plus or minus 1. Or maybe it does not change based on what was your performance on day number I. So it's dp of I minus 1 and 0 plus or minus 1. dp of I and 1 is going to be maximum of dp of I minus 1 and 0 and dp of I minus 1 and 1. It's going to be maximum of dp of I minus 1 and 0 and dp of I minus 1 and 1. Because this dp, this means that the last one is skipped, the last contest is skipped. But for the previous one, you might either you might skip the previous one as well, or you might not have skipped the previous one. And dp of I and 2 means that you have started your interval that you're gonna skip, but it is now finished. I mean, this interval is now finished. I mean, at position I, it will finish. It cannot survive after this. So basically, it means that this one cannot be skipped. So previously, you can look at it. You can look at the previous ones. Before it, you were either in the second state or you were on state 1. So you have to update it from dp of I minus 1 and 1 or dp of I minus 1 and 2 and see that what is your rating in these 2 cases. Take the maximum of these 2 and see that what is the effects that you're gonna have on that. So basically, you can define 3 dp's. And these 3 dp's can easily be calculated using the previous dp's. And this way everything can be calculated. Does this make any sense? You did not get the problem? So far, I mean, if you guys understood it, please put a plus or use this emoji. And if you haven't understood it, put a minus in the chats. So that I can have some... I can know something if you understood it or not. So you ask that what is the problem statement. What is DP? I mean, if you don't know what is DP so far, I really recommend you to first watch the topic streams. I have talked about DP in detail in the previous topic. Maybe let me show it to you as well. If you guys don't know what DP is, go to here in my main page of my YouTube. You can just click in here and in new tab. Just you can go to this Friday's topic stream. You can see about dynamic programming in here. I have a video about it. I have 4 videos about DP. This one, the second episode of it, and the third episode of it is here. And also I had a problem solving session on DP. You can take a look at these videos on this topic to see what is a DP. And about the problem, I mean, what is the problem? The problem is that you have a rating. You are participating in a contest. You have a rating. Each time in the contest, you have a performance. If your performance is greater than your current rating increases. If your performance is equal to current rating, your current rating will remain unchanged. And if your performance is less than your rating will decrease. I mean, this is the third conditions that you have. If AI is less than X, your X will decrease. And the point is that you can just choose an interval and skip all the contests in that interval. Then they will not have any effect on your rating. If you do that, they will have no effect on your rating. All the contests in the range from L to R. And the point is that if you skip an interval of the contests and skip them, at the end you want to maximize the rating that you can have. For example, in here, if you skip this range and do not participate in these contests, your rating starts from 0. Then here, this performance is greater than your current rating. Your rating becomes 1. In here, it becomes 2. Then these contests will be skipped. Then in here, it becomes 3. In here, it becomes 4, and the answer will be 4 this way. But if you were not skipping these contests, after that, in here, your rating was 2. In here, your rating will go back to 1 because your performance is worse than your current rating. It will go back to 1. Then in here, you have a performance of 3. It will increase by 1, so it becomes 2. Then in here, again, you have a good performance, and your rating will become 3. So the point is that by skipping an interval, you can increase your rating. You have to say that what is the maximum rating that you can have. Is the statement clear now? Are you okay with the statement so far? Suppose if we could rearrange the array and had to do all of them, would rearranging change the result? If we could rearrange, the most optimal way was to sort the array. If we would sort the array so that worse performances would be matched with when we had worse ratings, so maybe they could also increase our rating. If we want to maximize our rating, if we could rearrange them, it was the best if we would sort them in increasing order and participate in contests one by one. If we wanted to minimize it, it was the best to sort them in decreasing order. If we just wanted to rearrange them. So can we say we want to remove the, yes. Okay, a statement is clear, okay. So let me now talk about it in here. I said that I have 3 states for my DP. DP of ion 0, DP of ion 1, and DP of ion 2. DP of ion 0 means that I have not yet started my interval that I'm gonna skip. So it means that what is the maximum score that I can have if I only consider the first I contests and I have not skipped anything yet. So it's DP of I and 0. And it can easily be calculated from DP of I minus 1 and 0. Because in I minus 1 I have also not started my intervals, and then I can see that how it would change. So is DP of I and 0 clear? Only DP of I and 0. Is it clear? DP of I and 0 means that I have not started my interval that I want to skip. If it is clear, please put a plus or use this emoji. I will also show you code as well. First I'm just explaining it. I mean, if DP of I and 0 is clear, please put a plus or use this emoji. Okay, dp of I and 0 means that if I have not started my interval. I will quickly explain it and then I'll show you code. In showing code, you will understand better, and maybe you will see other solutions as well. So this is dp of I and 0, and then we have dp of I and 1. dp of I and 1 means that we consider the first I numbers, and we can choose, we have started an interval to skip, and that interval is not finished yet. So what I mean is that we can still extend it. So dp of I and 1 means that I have came to I and have started the interval that I want to skip, but I still can extend this interval. I can choose the next one and extend that one as well, and again choose the next one and extend and skip that one as well. So it means that this last element is skipped as well. This last context was skipped as well. So I'm saying that because basically we're gonna have only 3 states. Either I have not started my interval that I want to skip, or I have started it and I have not finished it yet, or I have started it and I have finished it as well. If I have started it and I have finished it as well, so basically when you skip an interval, all your contests will be in one, everything will be partitioned into 3 parts. You have part 1 here, everything that is before your interval that is skipped. You have part 2 here, that it is everything inside the interval that you skip. And this is part 3, this is everything that is after the interval that you have skipped. So basically I'm conditioning that I is gonna be in which of these 3 parts. I is either gonna be in the first part, then this can be easily calculated, or it's gonna be in the second part. Then I will say that I minus 1 is either in the first part, or I minus 1 is also in the second part, or I is in the third part. Then again I minus 1 is either also in the part 2, which is the third part, the part after that skip, or I minus 1 is in part number 1. So it's the part that is skipped. And I can see that what is the effect of this new contest that will be added. So basically what I mean is that my contests are in 3 possible cases. They are either before the interval that is skipped, or it's in the interval that is skipped, or it's after the interval that is skipped. And I can say that, okay, where I is gonna be. I have these 3 cases, and each one of the cases can easily be calculated. And this way I can see what is my answer. Does it make sense now? Right side is not visible. Did you understand? Could you understand it or not? Was it understandable or not? If it's not, maybe I can explain it again. I will also show you a code as well. So basically what I'm saying is that we are trying to skip an interval of the contests. We want to skip an interval of the contests. And then I say that we are going to have 3 parts. All the contests before this skipped interval, all the contests during this skipped interval, and all the contests after this skipped interval. So I have these 3 cases. And I can say that I is going to be in this first, in order to conform with our states, let's name them from 0 to 2, 0, 1, and 2. So dp of I and 0 means that I is in here. This can be easily calculated. I and 1 means that my I is going to be in here. This can also be easily calculated as well, because I know that I will be skipped. Now I minus 1 either has states 0 or has a state 1. Or I and 2. Again, I minus 1 is going to be either in a state 1 or it's going to be in a state 2. So I consider each one of these states differently, and I will calculate each one of them. I will calculate that what is my answer in each of these cases using a DP. And I will calculate the values of these DPs, and at the end, I will easily find out what is my answer at the end. Because at least one contest needs to be skipped, at the end I have to just print DP of n and 2. Is it clear now? If it is clear, please put a plus or use this emoji. I try to write more in the center. Thank you very much for mentioning that. I try to write in the middle of the screen from now. Ending at I, starting at I not part of any talk. I mean, it's also possible that I will be in the middle of the interval. That's also possible. So basically, I mean, your three cases are going to be this. Your I is going to be in here, or your I is going to be in here, or your I is going to be in here. All of these are possible. Let me also show you a code as well, because that can help to see how others have worked with it. And guys, when you see the codes of the people in this submissions, they are automatically sorted by their size of their codes. So when you come in here and see the codes of the people, always the first code is the code that is the shortest. As you go forward, the codes are gonna be, the size of the codes are gonna be bigger. So you can always come and see the solutions of other people, because to see that the people who have coded it in a very short way, how did they implemented it? That might have some good things to see, some good things to learn, that how they did it in a very easy way. For example, this person have done this in a very easy way. If you take a look at it, let's see how has he done it. He has started with A and B and C. So you look at it. I mean, that's a very easy and small solution. So let's see that how they have implemented it. I'm personally very interested to see how they've done it. Updates A and X. Okay, this updates function only sees that if your current rating is X and your performance is Y, how your rating would change. He just says update A and X, C and X. Okay, so he just has implemented the exact same DP. The values of A and B and C for him is exactly that DP of I and 0, DP of I and 1, and DP of I and 2 that I was talking about. So A is that we haven't started the interval that we're gonna skip yet. B means that we have started it. And C means that it is finished, it is ended. And now we are in the third part. So he first starts with this part, and the point that he says that if B was greater than C, let's say C is equal to B, and if A is greater than B, B is equal to A. He's saying that, I mean, he just tries to get maximum of the previous one. This is how exactly in here, we said that DP of I and 1 can be updated from DP of I minus 1 and 0, and also DP of I minus 1 and 1. And 2 can be updated from 1 and 2. The point is that each of these ones can be updated from the previous ones as well. So this one is exactly the DP. I mean, he just implemented in a shorter way. But let's see if there is a solution that is more understandable for you guys as well. Yes, this code looks very good to explain the idea. So he first defines DP of size n by 3. N by 3, and he just make them int min. This int min is the smallest integer that is possible. He uses that because when he wants to calculate maximum, he wants to make sure that this integer is less than everything else. So this is minus infinity. You can look at it as minus infinity. So dp of 0 and 0 first is equal to 0. He says that if dp of I minus 1 and 0 was less than a, dp of I and 0 is going to be dp of I minus 1 and 0 plus 1, and the other cases. So this is exactly that dp of I and 0 that I was talking about. He says that if dp of I minus 1 and 0, but let's say he just keeps updating that. This is the case that interval hasn't started and hasn't finished. So nothing is in that interval so far. So we just need to apply all the ratings. This dp of I and 1 is exactly what I mentioned. It's maximum of dp of I minus 1 and 1 and dp of I minus 1 and 0. Because I is skipped. I is a context that is skipped. We are considering the case that I is in that interval that is skipped. So now I minus 1 is also either skipped or it is before the interval that is skipped. So I have to calculate the maximum of both of the cases. It's going to be maximum of dp of I minus 1 and 1 and dp of I minus 1 and 0. And then dp of I and 2 means that I is after that interval that was skipped. So I is not skipped itself and that interval is before it. It's going to be equal to maximum of dp of I minus 1 and 2, which means that I minus 1 is also after that interval, or I minus 1 and 1, which means that I minus 1 was inside that interval and it was the last element that was in that interval. And then he just updates that dp. And at the end, he sees max of dp of n and 1 and n and 2. So this code is a very good code. Let me also share the code with you. It's a very good code that you can take a look at it, and this gives you an idea of how this problem can be solved. Is it completely clear now? If it is clear now, please put a plus or use this emoji again. I'm sorry that it might look a bit complex. If there is any doubts that you might have, let me know. Definitely let me know if there's any doubts that you might have. This one was maybe a bit more complex, but I hope that it is more clear now. Do you stick to one problem or do you move to others when unable to solve? Got stuck in CGIF 2 hours without any clue. If you got stuck on a problem for 1 hour, then you can take a look at the next problems as well. But usually the problems are sorted in by their difficulty. So usually it's the best if you stick to the problem that is not solved. But if you stick on it for a long period of time, it's good to check the next problems as well. Because sometimes it happens that you do not accept C, but you will accept D. It's very rare, but it happens. So you can also check that out. Nice. If there's any doubts in that, let me know. And I definitely urge you to watch that topic stream that I made about DP. I have talked about many of these things before. I definitely invite you to watch that topic stream that I made about DP. That's gonna be super helpful for you to understand what is DP and how you can use it. Let's wait for it to be loaded. I mean, if you take a look at it, I've talked about many DPs and how you can use these DPs, and this can be super helpful to understand what DP is. You need to make first some background about DP, solve some problems from DP first, and once you've done that, it would be easier for you to understand what these DP problems are about and how we can define these states, etc. So first, let's try to watch these DP sessions. And then you can, if you take a look at it again, it would make a lot more sense for you that how these DPSs are defined and how you can use them to solve the problem. So, you guys prefer to have a dry run, or do you prefer to move on to problem D? What do the most of you prefer for now? Do we solve problems by rating or by topics as beginner? As a beginner, it's good if you start solving by rating. That's what I did personally. I sorted Codeforces problem. I sorted them from the easiest problem, and I started solving so many problems. I mean, that was basically. I mean, my first objective in Codeforces was to get 100 accepts, and then when I reached 100, I tried to make it 400, 500. This is for when I had a very low rating. This works very well for me. For me personally, it worked very well. I mean, if you take a look at it, I was here. After a few contests, I got here. So for me, it worked very well. I sorted the problems. I started to accept so many problems. It was very good for me. I also suggest that to you, to sort problems. Try to increase your accepts. If it was me, I would put a challenge for myself to get 400 accepts on Codeforces. If it was me, I would do that. if I would start competitive programming all from the beginning, I would do it again, because I see that when I've done it, it had a massive effect on me. I learned a lot. Especially, I read a lot of people's codes, and that was super helpful as well. I learned a lot of things by reading people's codes. So, okay. Which type of problems I should okay, wait, okay. Do not spam. I have talked about it as well. I mean, if you again take a look at this, I made a guideline for people if you have started recently, if you are a newbie. I talked about which topics you have to solve. Let me send this one as well. As I have talked in these two videos, you have to solve implementation, brute force, and math problems, especially when you start. When you start, focus on these topics: implementation, brute force, and math. These are the most important ones when you start with. How many problems did you solve for each rating? I do not remember, but I remember that I solved the whole first page of Codeforces. When I sorted the problems here, in the problem sets, when I sorted all the problems, I mean, back then it wasn't by difficulty. What I'm talking about is 2015. It just had the number of people I've solved. But when I did that, I mean, I solved the whole first page back then. The whole first page of the day. And then I moved on to the next pages and solved them as well. And I remember that I got around 500, 600 accepts, and they were almost a prefix of the problems. So I did a lot of easy problems as well. I remember that I was doing more than 10 problems a day. And I personally learned a lot from it. I'm talking about my own experience. I learned a lot about it. When I was stucking at a problem, then I was taking a look at other people's solution. Especially from reading other people's codes, I learned a lot. So I would definitely suggest to you to consider that as well. Okay, guys. Do you want to move on to problem D, or do you want to dry run on C? Which one you prefer? And about E, I guess we won't. I think we won't talk about problem E today. As I said, this discussion unfortunately is going to be a shorter one, because today I wasn't available for the contest, and we're gonna solve until D. So yeah, this is what I told at the beginning of the stream, and I wanted to repeat again so that I don't want to keep you waited for that problem if you're waiting for that one. Do you want to dry run on C or move on to D? Right now it's 2-2. If you're stuck at newbie, take a look at that video that I sent. This is exactly for you if you want to get out of newbie. Okay, I think there are more people who want to move on to problem D. I don't want to leave the rest here as well, honestly. So I give you a short explanation here because I don't want to ignore all the people who wanted to dry run here. So I very shortly explain something very short, and then we will move on to D so that I won't keep the rest of you waited as well. So I mean, basically, if you take a look at it, dp of I-1 and 0 means that, I mean, this is what we use to calculate dp of I and 0. dp of I and 0 means that we haven't started the interval that is going to be skipped. dp of I and 1, it means that we are in that interval. dp of I and 2 means that we are after that interval. And each of them independently can be easily calculated. And if you take a look at it, for example, if you take a look at it in here, for example, when you come here, dp of 2 and 0 is 2, because your rating will be 2 if you haven't skipped anything when you get to here. dp of 2 and 1 is going to be 1, because this one must be skipped, this one must be skipped, and only this one can be used, so your maximum rating will be 1. And dp of I and dp of 2 and 2 is gonna be 1 again, because at least this one is skipped and this one is not skipped. And then when you come here, you have two choices. Either you skip this one, or you do not skip this one. So in here, again, if you consider dp of I and 0, your dp of 3 and 0 will be again 1, because in here your rating was 2. Again in here it will get back to 1. If you skip this one, it will be 2, so dp of 3 and 1 will be 2, because you will skip this one, and dp of I minus 1 and 0 was 2, so it will be updated from the, it will remain 2, and dp of 3 and 2 means that you have started that interval and you have finished it. So you were 1 previously, I mean dp of I minus 1 and 2 was 1, and it remains 1 as well in here. So this is basically how you can use. I try to very shortly explain that. I hope that it helped for you, and sorry for that if it's not enough for you guys. You can always take a look at any part of the video in here if that helps for you. Thank you very much, Osama. I'm so glad if you guys understood this, but I'm sorry if some of you didn't completely understand it. You can always take a look at the video, any parts of the video you want in here, and if you still have some doubts, you can still tell me in the Telegram channel. You can still message that in the Telegram channel and tell about that. Let me send you the link of the Telegram channel again. If you still had doubts, you can talk in Telegram channel. Okay, so let's not keep the rest of it and move on to problem D as well. I haven't thought about problem D before, so we're gonna solve it together. So it says that you are given an undirected graph with n vertices and m edges. You can perform the following operation at most 2 times maximum of n and m times. Choose 3 different distinct vertices A, B, and C. Then for each of the edges A, B, BC, and CA, do the following. If the edge does not exist, add it. On the contrary, if it exists, remove it. A graph is called cool if and only if one of the 2 following connections, the following holds. One of the 2 following conditions. The graph has no edges, or the graph is a tree. So you want to either make the graph empty or you want to make it a tree. One of these 2. You have to make the graph cool by performing the above operations. Note that you can use at most 2 times maximum of n and m operations. It can be shown that there always exists at least one solution. Well, each time you can choose three edges and you can change them. I mean, you can use a triangle and you can change their state. If they are selected, you can deselect them. I mean, if they are, you will in your edges, you will remove them. If they are not, you will add them. Okay, so yes, there are so many people who solve a lot of problems. But you do not really need to solve 5,000 problems to get to candidate master. You do not need to do that, but there are some people who have done. I mean, it was fun for them, definitely, to solve a lot of problems. But you do not, all the people who have become candidate master have not solved 5,000 problems. Anyway, so basically when I see this problem, what I will think about is this. I mean, you can use 3 edges, a triangle, and change the state of all 3 of them. And if afterwards you will choose these 3, the point is that this middle edge will be changed twice, so it will have no effect. It will be removed. I mean, it's like it has not changed, and it's like you just have changed a cycle of length 4. And then again, you can take a look at it like this and change a cycle of length 5, and then you can again add 1 other vertices. So it's like you can make any cycle that you want, and it's like basically it's like you can check, you can pick any cycle and change its state, kind of. So let's see that how people have done it. I think that with just playing with this operation, with just playing with these cycles, you can easily just remove the cycles, and you know, basically any path of length k can be replaced by a single edge this way. Because I mean, basically what I mean is this: if you have 2 edges, you can delete these 2 edges and add this edge instead. And then again you have another edge, you can delete again these 2 edges and add this edge instead. So I'm saying that any path of length k can be replaced by a single edge. You can kind of look at it like this as well. So let's see what have other people done exactly. So in here, in this solution, you have n and m, you have a for I from 1 to n, t of I is 0. You get j and k. If j was greater than k, swap j and k. Oh, it's interesting. If j was greater than 1, up 1 and j and k. So basically you delete the edge from j and k and add edge from 1 to these two. Okay, it looks like a very interesting approach. So you only have edges from 1. If you do this, at the end your edges are only from 1 to the other edges, to the other vertices. If t of I, p is equal to I, if not of t of I, 1 and p and I, so you add an edge from 1 to p. Now this is something that you do not have edge to. Wow, it was an awesome solution. Did you guys understand it? It was an awesome solution. I really liked the solution. So let's see. Yes, that sometimes happens as well. Let me tell you the question again and tell you the solution. The solution was very cool. So it says that this says that you are given an undirected graph with n vertices and m edges. You can do this operation. Choose a triangle and just invert the state of the edges. If they do exist, remove them. If they do not, add them. At the end, you want the graph to be a tree or have no edges. And with this number of operations, 2 times maximum of n and m, you want to do that. Well, the solution was like this. And it's a very interesting solution. It says that, basically, first of all, I want the edges, I want one endpoint of all the edges to be vertex 1. First of all, I want to make sure that all the edges have one endpoint at vertex 1. How do I do that? This is my vertex 1. Whenever I saw an edge, if one endpoint of it was 1, it's good. I do not need to do anything. If one endpoint was 1, then this edge has one endpoint 1, so it's okay. But if the edge was between two vertices greater than 1, for example, it was between A and B, let's do an operation on these three vertices, 1 and A and B. Then this edge will be deleted and the state between 1 and A will change and the state between 1 and B will change. So this is what you see in this part of the code. If j was greater than 1, first he swaps j and k if j was greater than k, and you say, this line was not very needed, but anyway. If j was greater than 1, he says that up of 1 and j and k, the edge between j and k will be removed and this edge between 1 and j and 1 and k will be inverted. If they were existing, now they do not exist. If they did not exist, now they exist. So t of I basically means that does 1 have an edge to that vertex or not? Okay, so is it clear so far? If it is clear so far, please put a plus or use this emoji. So first of all, I will try to make sure that all my edges are from 1 to one other vertex. So I do not have any edge between two vertices greater than 1. Is it clear? If it is clear, please put a plus or use the emoji, use this emoji. Okay, I will repeat. Okay, so I'm saying that let's forget about the cycles. I have not solved the problem yet. This is the first part of the solution. First of all, I want to just make sure that one endpoint of all the edges is vertex 1. I want to make sure that for each edge, one endpoint of it is vertex 1. at the beginning. And how do I do this? I say that for each edge, if both endpoints were greater than 1, let's choose those two vertices with vertex 1. If you got an edge between, for example, in this code, you got an edge between j and k, and you saw that both j and k are greater than 1. You will choose 1 and j and k, and by doing this, this edge will be removed, and the state of these two edges will change, will invert it. If they existed, they do not exist anymore. If they did not exist, now they will exist. So the edge between j and k will be removed, and the state of these two edges will invert it. So basically, at the end of the day, we will not have an edge between two vertices greater than 1. One endpoint of all the, at the end, your graph will look like this if you do this operation. You have vertex 1, and all the edges are vertex 1 to other edges, to other vertices. 1 does not have an edge to all the vertices, but all the edges, for example, there's an edge from 1 to 2, there's an edge from 1 to 5, and there's an edge from 1 to 7, for example, at the end. So by doing this operation, all the edges have one endpoint at vertex 1. So far, I made my graph like this. So the graph will be so structured this way. If it already has the edge will be removed. It will be removed, yes. If the edge currently exists, it will be removed. So you see that T of j will be XORed with 1, and T of k will be XORed with 1. So if they were 1, they become 0. If they were 0, they become 1. Is it clear now? Does it make sense now or not? If it makes sense, again, please put a plus or use this emoji here. And if it does not, let me know to repeat it. I want to make sure that all of you completely understood. J signifies that there's an edge between j and k. I mean, in here, you see in j and k, there's an edge between j and k. And I say that if j was greater than 1, just do an operation on 1 and j and k. And then, when you do this, T of j, T of I means that if there is an edge from 1 to I or not. T of j will be XORed with 1, and T of k will be XORed with 1 as well. Okay. So now that we know this, all our edges have one endpoint at vertex 1. So our edges are from 1 to the other vertices. Now the strategy is like this. These are all the vertices that we have. One has edge to some of them. One has an edge to some of these vertices. And our strategy would be like this. We move on all these vertices, and we find out the last index such that T of I is true. In other words, it's like the last vertex that vertex 1 has an edge to. So P is going to be equal to the last vertex that I has an edge to. And then we say that we have another 4, and we say that if T of I was 0, it means that we do not have an edge from vertex 1 to that vertex. What I would do is this. We would choose 1 and P and I. So our state is like this. 1 has an edge to P and has not edge to I. So there's no edge from 1 to I. And there's also no edge from I to P. Because we said that all the edges so far have one endpoint as 1. And we have not got to I yet. So I has not edged to anything else so far as well. So I is an isolated vertex. And I would say that at the end, I would just choose these three vertices. And if I do this, this edge will be deleted. And instead, these two edges will be added. Is it clear? Do you see it completely? No, the graph will not be unconnected. The graph will be connected as well. Because if you take a look at it, let me see if you saw it completely. Okay. So the graph will not be disconnected because Basically what you're doing in here is that this is your vertex P, right? This is your vertex P. The edge from 1 to P will be deleted, but instead both of 1 and P will be added, will have an edge to I instead. So I will come into this connected component as well. It's kind of like, if I go back to this code here, it's kind of like if you had this edge from 1 to P, it's kind of like you're adding I to the middle of it. So previously 1 had an edge to P, now 1 has an edge to I, and then I has an edge to P. So it's like you put I in the middle of it, and your new P will be this I. So next time when you see another vertex, you will add that vertex in the middle of this too. So this way at the end, those vertices that are not inside, they will come inside, and you will have a tree at the end. And if P was 0 at the end, it means that you right now don't have any edges. So your graph is empty, so you do not need to do anything. You only do this if P was not 0, if there is at least one vertex such that 1 has an edge to that vertex. Okay. So at the end of the day, if 1 had edges to no vertex, the graph is empty, that's good. Otherwise, let's pick one of the edges from 1 to another vertex like P. Each time when we see an I, it's like we add I in the middle of this edge. We can choose these 3 vertices, 1, P, and I, and then this edge will be deleted, and an edge will be added from 1 to I, and an edge will be added from I to P. So it's like instead of edge 1 to P, I'm gonna have edge from 1 to I, and then from I to P. And then these vertices will be included as well. No, at the end the tree will not be a star, because let me do a dry run on this one. I think this would help. So far we know that all the edges are from vertex 1 to other vertices. Assume that vertex 1 has edges to vertices 3, 5, and 7. Assume that these are the edges, for example. So I see that I have some edge, and assume that n is 7 as well. We have 7 vertices in total. So what I would do is this. I will start from all the vertices. I will start from 2. So I have this vertex 2 here, this vertex 4 in here, and this vertex 6 in here. First of all, I see that I do not have an edge from 1 to 2, so I will choose 1 and 2 and 7. 1 and 2 and 7. This way the edge to 7 will be deleted, and an edge will be added from 1 to 2, and an edge will be added from 1 to 7. And my new P, instead of 7, my P was 7, my new P will become 2. Because now 1 has an edge to 2. So as you see, each time when I include another vertex, my new P will be that one. So it's like that edge that I had from 1 to 7, now in the middle of that I have inserted 2. I have edge from 1 to 2 and then from 2 to 7. And then I come to 3, I see that 3 has an edge to 1, so I will do nothing. Then I come to 4 and I see that 4 does not have an edge to 1. So again, I want to insert it in the middle of this edge from 1 to 2. I will choose 1 and 2 and 4. So this will be deleted. Or let's use another color. This will be deleted, and an edge will be added here, and an edge will be added here. So again, it's like from the edge, in the edge from 1 to 2, I have added 4 in the middle of it. Now I have an edge from 1 to 4 and then 4 to 2. So 4 is going to be my new P. Again, I come to 5, I see that it has an edge, so I do nothing. I come to 6, and I see that it does not have an edge to A, so I need to add an edge. I will delete this one, and I add an edge from 1 to 6, and from 6 to 4. So it's like, again, now I've added 6 in the middle of the edge from 1 to 4. And this way, all the vertices will be included at the end, and I'm going to have a tree at the end. And also, if one had edge to no other vertices, my graph is empty, and that's going to be good. I do not need to do anything. Does it make sense now? Is it completely clear, guys? If you have any questions, let me know about it. Otherwise, after the first operation, choose one and edges which does not. I will choose all the vertices that 1 does not have an edge to. And for all those vertices, I will try to include them in an edge that I have from 1 to something else. And it's just enough to choose 1 and that vertex and another such vertex. There's no edge between 3 and 5 because I said that we make our graph in a way that there's gonna be no edge between two vertices such that none of them are 1. At the beginning, I said that if j and k are both greater than 1, you could say that if minimum of j and k is greater than 1, both were greater than 1, I can do an operation between 1 and j and k, and then that edge between j and k will be deleted. And I'm going to have an edge from 1 to j and 1 to k instead. The edges from 1 to j and 1 to k will be inverted. So basically at the beginning, I made sure that I have no edges such that one of their endpoints are not is not 1. All of my edges have 1 point, endpoint 1. So I'm sure about that. One endpoint of all the edges is 1. Okay. Awesome. There must be some reason that these series of operations would eliminate all the cycles. Well, yes. Basically, at the beginning, I'm just deleting all these edges from j and k. So at the beginning, I'm eliminating all the cycles because all my edges are from 1 to other vertices. So I cannot have a cycle because I mean all the edges have 1 points at 1. And I know that I do not have multiple edges between two pairs. So a cycle needs at least 3 edges. And because all my edges have 1 endpoint at 1, all my edges have 1 endpoint at vertex 1, basically it's not possible to have a cycle. Because if you have a cycle, those two other edges, those two other vertices need to have an edge to each other as well. But I know that all my edges are from vertex 1. So my graph would look like this. My graph would look like this, so it does not have any cycles at the beginning. Now I just want to make it connected. And in order to make it connected, each time I take another vertex, I want to put it in the middle of this edge. And this way I will add the vertices one by one. And this way at the end, I'm going to have a connected graph. Yes, it was a very cool solution. Okay, nice. Nice, guys. Okay, tomorrow I will see you guys again in the next topic stream that we're going to have. And in the next, contest solution discussion that we're going to have. Tomorrow is a contest and I'm going to solve it again for you guys. And I hope that we can also have a good stream tomorrow. Also, we're going to have a topic stream on DP Bitmask in our next session. In our next topic stream, you can still join our Telegram channel. You're more than welcome to join our Telegram channel. In there, we're gonna have more polls to find out what the topic streams of the next sessions are gonna be. So see you next time, guys. Basically see you guys tomorrow. Have a good day or night right now, and thank you very much for joining today. Bye bye.